In this lesson, the target states, I can evaluate square roots to simplify expressions. A number that is multiplied by itself to form a product is the square root of that product. Let's take a look at what that means. Let's break that down a little bit. A number that we multiply by itself, say n times n, the product of n times n is n squared. So the square root of n squared equals n. Therefore, it is the square root of that product. Let's take a look at a real example, like 2 times 2 equals 4. A number that is multiplied by itself to form a product, so 2 times 2, a number multiplied by itself to form a product, well, the square root of that product is the number that you multiplied by itself. So when you find the square root, you're kind of answering this question. What times itself equals that number? If I were trying to find the square root of 64, my question is, what times itself equals 64? Well, 8 times itself equals 64. So the square root of 64 equals, you guessed it, 8. There are some common square roots you should know because they are perfect squares. For instance, the square root of 9. What times itself equals 9? Well, 9 is the product of 3 times 3. So the square root of 9 is 3. What times itself equals 16? Well, 16 is the product of 4 times 4. So the square root of 16 is 4. The square root of 25 is 5. The square root of 36 is 6. The square root of 49 is 7. The square root of 64 is 8. And there are others you should think about trying to memorize. The square root of 81 is 9. The square root of 100 is 10. And that helps us understand what a perfect square is. Because if we look at this square, if the area of this square were 100, to find that area we multiplied two sides together. But the two sides of a square are the exact same length because it's a square. So to find the area of this we would do n times n. So what number times itself equals 100? You're right, if you thought 10, because 10 times 10 is 100. So the side length of this square is 10. Well, let's look at that using a square root, because we could take the area of a perfect square and take the square root of it, and it would give us the length of a side in a perfect square. So if there was a square that had an area of 25, the square root of 25 is 5, so I know one of its sides is 5 units long. Okay, let's take a closer look at square roots, because at this point you might be thinking, that's pretty easy, or I already knew this. But it's actually a little more complicated than this. Because when we're answering the question, what squared equals 81, we're trying to find the square root of 81. The first thing that might come to mind is, well, that's 9 times 9. 9 times 9 is 81. So the square root of 81 is 9. But hold on a minute, because as we learned in previous lessons, there's another way to get positive 81 by multiplying two numbers that are the same. Because a negative times a negative equals a positive, then negative 9 times negative 9 also equals positive 81. So sometimes we have to answer the question. Give the positive and negative square root of a number. The square root of 81 could be plus or minus 9. In some situations it wouldn't be the minus 9, like finding area or the length of a side of a square, but the square root of 81 could be given as plus or minus 9. So what's the square root of 9? Give the positive and negative value for the square root of 9. The square root of 9 is plus or minus 3, because 3 times 3 equals 9, and negative 3 times negative 3 also equals 9. So what's the positive and negative value of 256? This would be another one of those perfect squares I said you should try to remember. The square root of 256 is 16. So plus or minus 16 is the square root of 256. And one more thing, sometimes it's not a perfect square. Some numbers are not perfect squares. So if I were trying to find the square root of 5, it'd be hard to do mentally. I know it's somewhere between 2 and 3 because 2 times 2 is 4 and 3 times 3 is 9. And 5 falls in the middle of 4 and 9. It's closer to 4, so I know it's going to be a number closer to 2, but I'd have to use a calculator for this. I'd get out a calculator and use the square root button and put the 5 inside it to get 2.23, and that number would go on maybe forever. But sometimes you can use a calculator to find the square root when it's not a perfect square. So here's a couple common problems you could face when using square roots. For instance, dealing with area. You know the game Foursquare, where you build a big square and it has 4 sections and you bat a ball around with some friends? Well, the area of a 4-square court is 256 square feet. So a good question would be, what's the length of a side of one of the sides in a 4-square court? So really what we're asking, given the area of this square, find the length of one of its sides. So what times itself is 256? So this answer could be given simply if we just do the square root of 256. What times itself is 256? And the square root of 256 is 16. So a good answer would be 16 feet. In this case, we wouldn't use plus or minus 16 because it's related to the length of a side and it's going to be a positive number. Another common thing you have to do with square roots is evaluate them. They fit into order of operations problems because taking the square root of something is an operation, you have to do it. And it's also a grouping symbol. So it's kind of along the lines of being a parenthesis or an exponent, because exponents come first, and so do parentheses. We often have to evaluate the exponent or square root first. So in this problem, I would do the square root of 25 first. So what's this 3 doing out here? What operation goes in between the 3 and the square root? Well, it's multiplication. It's 3 times the square root of 25. So the square root of 25 is 5. So it's 3 times 5 plus 4. The next step in the order of operations is multiplication, so it's 15 plus 4, or 19. In the next problem, the square root symbol is covering a division of 16 divided by 4. I have to go inside the square root as if it's in parentheses and do this first. First thing I'm going to do is the division. It's 16 divided by 4, or 4, and the square root, being the grouping symbol, comes next. So right now my problem is square root of 4 plus 1/2. Square root of 4 is 2, plus 1/2, my last step is to add, would give me 2 1/2. Okay, now you try. Click pause, copy and solve these problems, then click play to check your answers. There's 5 questions all involving evaluating square roots. For numbers 1, 2, and 3, give the positive and negative square root of each problem. For number 4 and 5, use the square root symbol in the order of operations to evaluate each problem. Good luck. For number 1, the square root of 16. There are 2 things you could multiply by itself to get 16. That would be plus or minus 4. Positive 4 times positive 4 is 16, and negative 4 times negative 4 is also 16. For number 2, the square root of 121, the answer would be plus or minus 11, because 11 times itself is 121. For number 3, what number times itself is 400? That would be 20. Positive 20 or negative 20. So it'd be plus or minus 20. For number 4, just remembering what operation goes in between a number and a square root. It's like a parenthesis, so it's something along the lines of 2 times the square root of 36. When a number's next to a parenthesis, it means multiply. So my first step is going to be to take care of my square roots, just like I would take care of my exponents first. So this is 2 times 6 plus 5, because the square root of 25 is 5. 2 times 6 is 12, plus 5. My last step is add, and I get 17. Last problem, number 5. First thing I have to do is the square root of 64. And I'm going to rewrite the problem. The square root of 64 is 8. So it's 8 divided by 2 plus 11. Division comes next. 8 divided by 2 is 4, plus 11 equals 15. How'd you do? Great job.